Hi, this is Ms. Park. In this video, we're going to cover a concept called limits. Okay, and we're going to do that using a little bit of investigation, but also a Google Sheets assignment. So in this video, I'll also introduce the assignment. Okay, so before we talk about limits, let's talk a little bit about paper folding. Right, if you had a sheet of paper, and you can go take one if you want, and you folded it in half, okay, and then you open it up again, your paper will look like this. It will have two halves. And after you fold it, if you fold it up a second time and then open it up again to count the rectangles in there, you would have 4 rectangles, right? And if you closed it up again and folded it a second time and folded it in half, you would have 8 rectangles. So what I'm going to do is I'm going to make a table of values. So I'm going to say n is the number of times you fold it, and rectangles is the number of rectangles you see. Okay, so before we ever fold the paper, there's one rectangle. It's just one sheet of paper. Once we fold the rectangle once, once we fold the sheet of paper once, we're gonna have 2 rectangles. When you fold it a second time, you're gonna have 4 rectangles, right? So the paper is folded in half and then folded in half again, and that will show you 4 rectangles. If you take that piece of paper that's been folded twice and folded a third time, and you open it up again, you should count 8 rectangles. So try it with a piece of paper to make sure. Okay, if you try to fold it again, 16 rectangles, and again, 32 rectangles. Okay, what do we notice about these numbers 1, 2, 4, 8, 16, 32? Right? From each number to the next, we are doing a multiplication by 2. That's because when we fold the paper, we're actually doubling the number of rectangles. Right? So each time is times 2, times 2, times 2. This is actually called, we can use exponents to simplify the way this looks. Okay, so when you fold the paper once, you have 2 to the 1 rectangles. So that's just 2. And when you fold the paper twice, you have 2 to the 2 exponent. 2 to the 2, which is 2 times 2. And then when you fold it 3 times, you have 2 to the 3, which is 2 times 2 times 2. So exponents means the number is multiplied by itself that many times. 4 times folding, you have 2 to the 4 rectangles. 5 times, you have 2 to the 5. So can we look at the pattern and say, if I folded this piece of paper n times for any number n, how many rectangles would I have? So I would have 2 to the exponent n rectangles. Okay, so hopefully that's okay. I'm going to show you something else. So that's not anything to do with limits yet, but now we'll do limits. So I'm going to take my piece of paper and I'm going to shade half of it. Okay, and so I'm going to make a table, and n is going to be the number of times I've shaded it. Okay, and then the fraction that is shaded. Sorry, I'm going to start with the fraction that is unshaded. I'm going to go first, and then the fraction that is shaded. Okay, so the first time I shade half, the fraction that is unshaded is 1/2. And the fraction that is shaded is also 1/2. Okay, now what I'm going to do is I'm going to take the unshaded part, okay, and shade half of it. All right, so now this is n is 2. That's the second time I'm shading. The fraction that's left unshaded is 1/4. And the fraction that is shaded is 1/2 plus 1/4, which is 3/4. The fraction, sorry, that is shaded, the fraction that is shaded is 3/4 and unshaded is 1/4. Okay, now I'm going to take that part that's not shaded and shade half. So this is n is 3. The fraction that's left unshaded is how much? So let's see if I can help with this picture. I might have to cut this up a little bit. There. Okay, so the fraction that's left unshaded is 1/8. And the fraction that is shaded now is 7/8. Let's do it one more time. I'm going to take the part that's unshaded and shade half. The fraction that's unshaded is that little rectangle up on top that's still not colored in. So what fraction of the whole rectangle is that? Well, you'll have to chop up the rectangle into smaller pieces so that you can see. Okay, and so you should see that that little rectangle up at the top right is 1/16. And what is the fraction that is shaded is 15/16. So can we figure out a pattern of what's happening? First of all, the fraction that is unshaded is getting smaller and smaller, right? As I keep shading parts of the rectangle, the amount of that paper that is being left unshaded is smaller and smaller. And then the fraction of the paper that is shaded is getting bigger and bigger. What's the largest fraction I'm ever going to get in the shaded column? Right? What's the biggest I can get? If I keep splitting this up and splitting it up, so I'll split it up again and shade and split it up again and shade and so on, this little square here becomes smaller. That little rectangle becomes smaller while the shaded part becomes larger. And what's the smallest that unshaded part is going to be is 0, but it'll never truly be 0 because you'll never truly shade right up to that corner. There's always going to be a little piece left unshaded because we're always cutting the unshaded in half. Okay, and then the larger, it's going to get bigger and bigger, but what's the largest it could be? Well, the largest it could be is 1, because eventually I'm going to shade the whole paper, but I'm never really going to hit 1 because there's always going to be a tiny piece that's still unshaded. Okay, so we call that the limit. Okay, the limit is how far you can go, and even if you don't ever reach the actual limit, like in our case, we're not going to reach the actual limit because there'll always be a piece unshaded. It's still called a limit. Okay, so the fraction that's left unshaded, the limit is 0. Okay, so that's so you come closer and closer to it. That's the limit. You come closer and closer to it. And then the fraction that is shaded, the limit is 1, because theoretically, eventually I'd shade the whole paper, even though like in reality, there's always going to be that tiny little piece that's left unshaded. If I had to make a formula for this, I would say after n times that I'm shading, notice those powers of 2 again. Remember the powers of 2 from over here? 2 to the 1, 2 to the 2, 2 to the 3, right? 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16. Well, it's the same thing over here. Notice this is 1 over 2 to the 1, 1 over 2 to the 2, 1 over 2 to the 3, and 1 over 2 to the 4. So after n times that I'm shading, the fraction that's going to be unshaded is 1 over 2 to the n. And the fraction that's left shaded is still something over 2 to the n. What would go up on the top? It's always 1 less than the denominator because there's always that one tiny little part that's not being shaded. So it's 2 to the n minus 1. But you don't even need that. Let's focus on this one. Okay, so this one is more important. Okay, this is the other formula is a little hard to look at, but just so you understand, so the limit of what's unshaded is getting closer to is 0, and the limit of what's shaded is 1. So now I'm going to take you to the Google Sheets, and we're going to make a table that looks just like this using formulas. All right, so remember the table with the n, 1, 2, 3, 4, and then those fractions. So let me show you how to do that. Okay, so here we have a Google Sheets assignment. The instructions are all on the first page, so this is in your Google Classroom. It's step-by-step instructions of what to press, like what formulas to put in. At the bottom of the first page of instructions, there's a tab called Limits of 1 over 2 to the n. So I'm going to click on the tab, and it's going to show us a table. Okay, so I'm going to put in. So the first column says term number n, and then the second column says power 2 to the exponent n, then value of 1 over 2 to the exponent n, and then the running total. So that 1 over 2 to the exponent n, you can think of it as the part that's unshaded, and the running total is going to be the part that's shaded. We're going to keep adding. Those fractions together, and hopefully we'll find that the limit of this column C is going to be 0, and the limit of this column E is going to be 1. I'll just start you off, if you've never used Google Sheets, to create the ends, okay, to create the table of ends, we're going to put a 1. I'm going to put a 1 in the first cell, and then I'm going to put a 2 in the second cell. Okay, and then Google Sheets is pretty smart. It'll continue the pattern. So I'm going to highlight both cells, and you'll notice that at the bottom right, there is a blue square. If you drag the blue square, you can drag it as long as you want. It'll fill in all the numbers for you, right? So what we want with this assignment is that you use the features of Google Sheets. And even though they're going to be new for you, please don't type numbers in. Okay? Never type numbers into the Google Sheets. We're always going to have Google Sheets fill in values for you using formulas, right? So now for the second column, I'm going to put my cursor on this B2. And then for the second column, I want to put a formula that is 2 to the exponent n. So for this first row, it's going to be 2 to the exponent 1. For the second row, 2 to the exponent 2, then 2 to the exponent 3. But I don't want to be typing in those values 1, 4, 8, 16. I don't want to type them in myself. I want Google Sheets to do it. So this is where we're going to put in a formula. I'm going to click on the first one, and I'm going to put a formula. In Google Sheets, formulas begin with an equal sign. So I'm going to put in an equal sign. All right, let me zoom in a bit. Let's see if I can zoom in for you so you can see it. No, I don't think I can. Can I zoom in for you? No. Okay, so ignore that. All right, so I'm going to put in a formula, and the formula says take the value of A1. No, sorry. The formula says take 2 and raise it to the exponent that is the value of A1. Exponents in Google Sheets is Shift 6. Shift 6. It's like a little caret, it's called, or a small, like a hat, or accent circumflex in French. Okay, and then we're going to put the exponent is A1. No, didn't like that. So it gave me an error. I think probably because I typed all over the place different things. Error. Yeah, it doesn't like it. Okay, so let's go. Let's see. 2 to the exponent A2. Oh yeah, it's A2, right? It's row 1, but but the first row is actually my headings. It's my titles, so it's really A2. So here we go. That should work. Okay, so this is 2 to the exponent 1, and if I put my cursor on it, if I put my cursor on this row B2, I can look for the blue square at the bottom and drag it down, and watch what it's going to do. It's going to fill in all of my 2 to the exponent 1, 2 to the exponent 2, 2 to the exponent 3, and so on. Okay, so that's how we get Google Sheets to do all the work, so we don't have to do all the work. All right, so your instructions on the first page are going to tell you exactly what to type, okay, so that you can fill in all those columns. And then once you've filled in all those columns, it's going to show you how to create a graph. All right, once you've filled in the columns and you've made a graph, the graph is going to show you the limit. One of those columns is going to approach 0. The other column is going to approach 1. And you'll be able to see that with the graph. Once you're done everything, just submit in Google Classroom and you're done the assignment. Okay, thanks for watching and good luck.